Aerogels are the lightest solid materials on Earth. Aerogel is so light, it's said that this material can balance on a dandelion without even deforming the individual seed heads. Despite being so light, they can support 500 to 4,000 times its own weight. What makes aerogel so fascinating and invaluable is their ability to insulate while weighing little to nothing. Here, a 5.5-pound brick is supported by a piece of silica aerogel weighing only 2 grams. The legend of the aerogel is still a bit of a mystery. What we do know is that in the late 1920s, American chemistry professor Samuel Kistler had a bet with colleague Charles. After much trial and error, Kistler was the first to successfully replace the gel's liquid with a gas, creating a substance that was structurally a gel but without liquid. And by 1931, he published his findings. Aerogel begins as a gel called Alcogel. Alcogel is a silica gel with alcohol inside its pores. Simply evaporating the alcohol out of the silica structure would cause the structure to contract. Instead of just relying on evaporation, the gel has to be supercritically dried. The carbon dioxide inside the gel eventually surpasses its supercritical point, where it can be either a gas or a liquid, and is then vented out. This exchange is performed multiple times to ensure that all liquids are removed from the gel. The alcogel with its alcohol removed is now called aerogel, as the alcohol has been replaced by air. Aerogels provide very effective insulation because they are extremely porous and the pores are in the nanometer range. The nanopores aren't visible to the human eye, and the existence of these pores make the aerogel so adept at insulating. The pores are so small, in gas phase, heat conduction is very poor. The molecules of air simply cannot travel through the aerogel, so there is poor heat transfer. Because of aerogel's notable insulating abilities, it has been used by NASA for many of their missions. In 1999, NASA launched a spacecraft with a tennis racket-shaped dust collector with 260 aerogel cubes in the hopes of capturing comet samples and space dust. Aerogel's durability allowed the dust collector to return from space intact with not a single aerogel tile missing. Scientists have been able to study the dust and crystals contained in the aerogel and await the insights that they may bring. The majority of aerogel is composed of silica, but carbon, iron oxide, organic polymers, semiconductor nanostructures, gold and copper can also form aerogel. Silica is the major component in aerogel. Another name for silica is silicon dioxide, a molecule composed of 1 silicon and 2 oxygen atoms. Silicon dioxide is the same stuff that sand, quartz, and glass are made of. Silica is a desiccant, meaning it adsorbs water. That means water adheres to the surface of the material. The silica gel can often be found in little packets in anything from shoe boxes to your beef jerky packets. Its absorbent properties prevent the growth of mold and reducing spoilage in any product. Johns Berzelius discovered silicon dioxide in 1824. He was a Swedish chemist who was instructed by Dalton. He is among many others as one of the fathers of chemistry. Silica has many widespread uses, including protecting paper from humidity, drying flowers, preventing rust on tools, preventing condensation on windows, preserving art and display cases, and many more. Silica is made from 2 raw materials, sodium silicate and mineral acid, which are used in a wet process to create a reaction in generating monomeric salicylic acid. These monomers polymerize to generate primary silica particles referred to silica sol. These particles then aggregate to form a 3-dimensional structure in a gel state. A fun fact about silica is that when it's put in water, the silica gel beads tend to absorb too much of the water, causing them to crack and make piping. Although aerogels might be one of the most expensive materials on the market, the future looks promising as the cost of production continues to decrease and the possibilities become more infinite.